your word count program, whatever is being executed by you, that is from your terminal, Hadoop zar /user /lib /Hadoop, something like this. /examples or Hadoop examples .zar, and you have specified the name of the job that you wish to run, and you have specified with a space, you have specified what is the input path. What is the input path? /tmp /sandbox /Mary, and the output path is /tmp /sandbox /Mary_out. This is what we did from the terminal, and I have explained you very in detail what is the meaning of this statement. Before that, we used Hadoop PFS. Our intention was to work with your file system. That is why we used Hadoop PFS. You want to run a zar file, then you will be using Hadoop zar. When your intention is to run a zar file, then you need to specify where that zar file is located. That may be anywhere on your local file system. Hadoop zar, you should tell where that zar file is located on your file system. In that zar file, there could be multiple jobs developed and packed by the developer, or there could be only one job. So hope all of you has got some basics of Java, if I'm not wrong. If you don't have the essential basics of Java, please talk to Sunil or Kavya to access some basics of Java, the self-paced course which is there with us, so that you will be able to get the essentials. It's not the complete Java program, but the essentials to work with your Java part. So inside a zar file, inside a .zar file, we can have only .class files. We cannot have anything other than that. We can have only .class files. Now, when you're developing a MapReduce based job, either you can keep one job inside or multiple jobs inside. If you keep only one job and make that as, observe closely here friends, and make that as your main class, I mean the entry for your zar file, then you don't need any job name to be specified while running it, because that is going to be the main class. You're following with me what I'm sharing here, friends? If there exists only one job and that is the main class or an entry to the jar file, then we need not provide the job name. Then we need not provide the job name. That can be avoided. Which can be avoided? This word count can be avoided. But inside the jar file, if you have more jobs and you wish to specify which job you want to run now, then you need to give that job name which you want to run. So with this, you have understood 2 points, friends. So inside the same jar file, you can have multiple jobs, and the jobs are configured with their aliases, like this word count what we have given here, and that particular job is going to run for you when you are given this jar file as an input. If there exists only one job and that itself is going to be the main class for the jar file, then we need not specify any job name there. When you want to run your jar file and a job, your basic intention of developing a MapReduce job is to process the data. As your intention of developing a job is only to process the data, you should supply or provide where that input can be found on your HDFS. Your intention is to run a MapReduce job on the cluster, not locally to your file system. So I need to specify the path where my file is located on HDFS. That is why this is a HDFS path. /tmp/sandbox/Mary. /tmp/sandbox/Mary_out is the place where the output for the given job is going to be stored. /tmp/sandbox/Mary_out. And we need to make sure, friends, here input path must exist, output path must not exist. If input path does not exist, an exception is thrown if input path does not exist. And here an exception is thrown if output path exists. You understand, friends, what I am sharing here? I don't know whether you experimented with this or not. If you might have experimented with this, you definitely appreciate. Why the input path must exist? That is the source where I read the data. When I read the data and process that one, the output needs to be stored in a location where that is freshly created, not in the existing, because if I give some existing path and if that is overridden, then probably my previous job execution output might have been overridden. That way, I will be losing the output of my previous job where I may need to rerun the job once again to produce that output. So keeping that thing in the mind, the output path must not exist. If it exists, it is going to throw the exception saying output path exists, which means by default it is not going to override with the new outcome that is produced from the job that you are planning to execute now. So if these are being taken care, then your job is going to execute properly and is going to produce the output in the respective output path what is being given by you. Everything works fine. So as part of MapReduce job execution, one. Then we have we have a mapper phase. Of course, most MapReduce jobs will have mapper and the reducer, two phases. That is where we call it as a MapReduce job. Or maybe mapper is the beginning and the reducer is the ending. So as this is the life cycle with which your jobs are going to run, might be they might have mentioned the technique that we are going to use as a MapReduce job kind of thing, leaving the intermediate phases not to be mentioned as part of the technology. So we call it as MR job or MapReduce job. It doesn't mean that we have only mapper and reducer. We have a combiner, partitioner, shuffle and sort, all these things as part of your. Hope you are following with me, friends, what I'm trying to share with you here. It makes sense? Prasad, Ram.
Yeah.
So we have a mapper, we have a combiner, a partitioner, shuffle,
Yes, we know have it.
then we have a reducer. Or we call it as a reduced phase, whatever it is. Yeah, please go ahead.
So, trying to understand, like, are we going to see the whole, set of files in the examples jar file that the MapReduce job we ran, so that we know, what all are enclosed in that?
Yes, yes, yes. No, I didn't get your question exactly. Come out once again.
I was asking, the MapReduce job that we ran.
Yeah.
Are we in the jar file, in case we want to write our own MapReduce job? So is that what you're explaining with the life cycle? Like, what are all we need to enclose?
No. What needs to be included inside your jar file is different that we do it with your Eclipse IDE. But when you are running a MapReduce job, because you have already executed a MapReduce job. So while running a MapReduce job, what life cycle it undergoes, that is what we are looking at.
Sure. So are we going to see the Eclipse one after seeing the life cycle?
Absolutely. No, we are going to write a MapReduce job in the Eclipse and see how we pack that into a jar file and how we run that jar file, because we have our own mechanism how you create a jar file, like how examples.jar. We create our own jar file and we run that one in the place of your Hadoop example jar. Maybe the word count, but still we write on our own and generate a jar file and see how it is. But before that, we need to understand what is the different phases that we have as part of the MapReduce job and what is the significance of each phase of your MapReduce job. You look at that closely here. You have a main method, you notice here, and you have a class. If you see this one closely, you understand. Public class my MapReduce job. public static void main, public static void main, string args, the place where we write the driver code to drive the MapReduce job. Like you see here, what is that been written? What is that been written? Inside your main method, job.set. What is a mapper class? What is a combiner class? What is a reducer class? What is the output key class type? What is the final output value class type? All being done inside the main method of the class what you developed. What is the output format? What is the input format? What is the input path? What is the output path? You can see that here. What is the input path and what is the output path? All these things, what all you mentioned here, all these things you mentioned as part of your main method. That is what we call it to be. That is what we call it to be the driver code, friends. It is a code with which your MapReduce job is being driven. Apart from that, now we are trying to understand the skeleton of a MapReduce job. I am not showing you the code present inside your mapper class, reducer class and all. I am showing you the skeleton. You have a class, public static class. See this one? Interesting, we have a class inside a class. This is what we call it to be inner class. Inner class. What is it available now? What is it available now? Public static class my mapper extends mapper, and inside this I'm going to write public void map. This takes some inputs. We write logic related to map phase of the job. Same like we have public static class my reducer extends reducer, and we have public void reduce, it takes some inputs, and we write the logic related to reduce phase of the job. So this is what we call to be the skeleton of your MapReduce job, friends. So what is that skeleton? You can go and see here. We have a class, public static class, whatever it is. We have a map function and its class been closed here. We have a reducer class and we have a reduce method and been closed somewhere here. Your main method, and finally the end of your main class. So I asked you a classical question here. What is the advantage of writing? What is the advantage of writing this static inner class here? With this, I can understand and estimate what level of Java skill set you have.
So whenever you are going to run the program, the whatever that static mat class value doesn't going to change.
No. The static in that context is different and static here is different. I appreciate, you know, you have, the knowledge you have in terms of the static variable. But even then it is not right. It is not going to be changed only when it is a final variable. If it is a static variable, its value can be changed any point of time. Only when it is a final variable, its value will not be changed. So as a variable is a final variable, constant, there is no need for us to create that variable each time. That is the reason why final variables we intentionally declare as static so that they get the memory exactly once, not each time you create an instance of that class. Hope you got that logic.
Yeah.
Final variables are nothing but constants. Constant values cannot be changed. Each time you are creating an object, why a final variable should get the memory? Because anyhow it is a constant, its value cannot be changed. We only use it wherever required. So we don't want to make final variables as instance variables, because each time you create an object to that class, say you have a class EMP, you are creating 100 EMP objects, 100 employee objects. Each time this final variable will get the memory. That is useless. Instead, we make that variable as a static variable so that the memory allocation to the static variable will be done exactly once. So, thereby you can avoid getting the variables each time you create the instance of that class. Now the question here is, what is the advantage of defining this mapper class inside this class as a static class? Why we are doing that? We are developing our mapper class extending from the existing mapper as a static inner class. We don't write inner keyword anywhere here, but we are writing this class inside the other class. That is why we obviously call this as an inner class. So why we are writing this as a static inner class is my question. Anyone, friends? Friends, anyone? Ram, Prasad, Hemal, yeah.
So it can access static data only, I can say.
It can access only static data. I don't agree. Because your class can access anything here. The reason behind it is the logic we write inside the map function is suitable to process only a specific data set in the given context. A specific data set in the given context, not the specific data set, everything. The logic we write inside the map function is confined to a specific data set. Again, the specific data set confined to one small incident or area. As a result, the logic we are writing here may not be useful to you in any other MapReduce job, then there is no point me developing this as an independent Java class. I want this to be visible or accessible only within your MapReduce job. That is the reason why if I make this as a static inner class, this is accessible only in the scope of my MapReduce job. Outside that, this is not visible. Outside that, this is not required. We are trying to couple the mapper class, the reducer class, the combiner class, partitioner class, and all these things as part. Public static class, my mapper extends mapper. So that the mapper phase of this particular, okay, the mapper phase of this particular implementation is accessible only within the scope of my MapReduce job, not beyond that. Not beyond that. And our intention is also the same. We don't want this logic to be used or accessed anywhere. By chance, anytime in future, if you feel same mapper is going to be useful in some other context, then what we do is we develop it as we develop the MapReduce job. We develop the MapReduce job as public class my mapper. We have public static void main. I advise you friends to please update your skill set on Java. Otherwise, in the coming days, it will be slowly it becomes Greek and Latin. I develop the class as public class my mapper. And here public void map. Same like I develop the reducer, and inside the main method, I'm going to fix the driver code like that. How I fix the driver code? I fix the driver code showing that this is a mapper class, this is a reducer class, this is a combiner class for this job. That is the reason why we are calling that code as a driver code. Driver code, don't get misread, friends. We are using the term called driver code for the reason that is the code with which your job execution is being driven. That is the reason why we are calling that as a driver code. I advise you to please go through this link, whatever I am sharing with you now. Open this one, friends, what I have sent in the chat. You'll be able to see the MapReduce job, the latest MapReduce job. And if you look at that skeleton, you have a main method in which you have the driver code, you have the mapper class, static mapper class, and you have the reducer static reducer class. Of course, in this we don't have any combiner or partitioner, but the reason why I am discussing this one now is to understand, is to make you to understand what are the phases actually there as part of your MapReduce job. What are the different phases you have in a MapReduce job? What are the different phases, friends?
Or combiner, partitioner, so far and sort and reducer.
All these are the phases. Now if you come back to this code, only look at this code, friends. Only look at this code. What is your understanding? What is your understanding, friends?
That one, there is no partitioner class, is there?
Yeah, the partitioner is not being mentioned. Shuffle and sort also not been mentioned. If you notice, shuffle and sort also not been mentioned. So you understand one thing here. Every phase of MapReduce job is needed for every MapReduce job attempt or for every MapReduce job execution. That is what you need to understand here. Every phase of the MapReduce job is not needed every time. But the minimum that you see every time is a mapper and the reducer. In most cases, a reducer class itself works as a combiner. Reducer class, you see here, for mapper there is a class, but for combiner and reducer we have the same class. You notice that here, friends?
Yes.
So, I mean, not in every case, but in most cases I am saying, in most cases, your reducer itself is going to work as a combiner also. The combiner is called local aggregator. The combiner is called local aggregator because your reducer is global aggregator. What do you mean by global aggregator? Global aggregator here means, don't think that global aggregator means beyond the job. It is all in the context of job only. At the job level, this is the top. At the job level, some aggregation is happening called global aggregation. You may ask me one thing, beyond job, what we have, Srinivas here? I already told you and discussed while talking about the introduction towards your MapReduce and the introduction towards big data. That time I mentioned your MapReduce is going to use massive parallel processing in the background. That is called MPP. So we have two techniques basically. Pull the data to the place where code is running. This is a traditional programming methodology. Traditional programming. This is a traditional programming methodology that we have followed in many contexts. What is a traditional programming methodology? You have the database available. From the database, we pull the data to the place where code is running inside the web server, and we process the data and we give the output to the end user. That works fine when you are pulling the data, limited amount of data when you are pulling, that works absolutely fine. But when it comes to the big data context, pulling 100 terabytes of data to one place and process it is beyond your visualization. Forget about 100 TB, even 4-5 TB, it is tough for us to pull to one place and you start running the code there. That is the reason why we have second alternative that is called push the code to the place where data is available. This is your MapReduce programming model. We are pushing the code to the place where your data is available so that data movement will not be there. When the data movement is not there, you are going to reduce a lot of time and thereby processing the data is going to be more efficient, is going to be more efficient, because getting all the data from different sources to one place and make your code to run or to process the data one after the other, that is in the sequential fashion, it may take 10 days, 20 days. Because your 100 TB of data, see, I'm essentially talking at the big data level, friends, not the small 2 MB, 5 MB data. It makes no difference with your pull the data model or push the code model against your 2 MB or 20 MB data sets. I'm talking about big data level. So at that level, what happens, friends? Your 100 TB of data being pulled to one place and processing it there, sequentially one after the other, is definitely going to be very expensive. Not to happen that only, what we are doing, we want the data to be there itself, so that we will be able to push the code to all those places where your data is present. Where your data is present, basically, tell me, where your data is present? Where your data is present?
HDFS. The data node?
Exactly, in the data node.
File system.
Yeah, you're absolutely right. You're absolutely right. So I'm saying where your data is present. Your data is present in multiple data nodes in the form of blocks. Say you have your 1 TB of data. Your 1 TB of data will not be there on one data node. Your 1 TB of data is chopped uniformly into 128 MB blocks, and those are being put in different data nodes. Say you have 10 data nodes, your 1 TB of data is being chopped into 128 MB blocks, and those blocks are being spread across the data nodes in a uniform fashion. Because your nodes should not be like this, friends. Your nodes should not be like this means one node fully loaded and the other nodes you have hardly few blocks. That should not be the case. There should be a balance across the data nodes. All data nodes should have the same load so that the processing is going to be efficient. Otherwise, if one data node has got more blocks, then when it comes to the processing, I need to keep certain blocks to be processed in the queue. I cannot initiate multiple JVMs beyond some limit on the same data node. It is not possible. Of course, I process the data parallelly. What you need to understand here is, friends, you need to understand this one. Within the data node, blocks get processed within the data node, blocks gets processed parallelly. Across the data nodes, blocks gets processed. What is this called now? What is this called, friends? Within the node, there are 10 blocks, assume. Those 10 blocks will get processed parallel, not like within the node 10 blocks are there, first block is processed, then second block, then third block. No. All 10 blocks will get processed parallelly. Of course, there is a small condition there. Provided if sufficient resources are available, I can have multiple tasks running within the same node. Each task is going to process one block. Each process is going to take one block. Each task, whatever the task that you are seeing there, that is going to take one block and process it. If there are 10 blocks within the data node, what is going to happen? All 10 blocks will get processed within the time of how much time it takes to process one block. Now, I have second node, in that also I have 12 blocks. Those 12 blocks also gets processed parallelly. Now, at the node level, if you see, there are 12 blocks present within it, all gets processed parallelly. At the cluster level, we have 10 nodes. In all the 10 nodes, if data is really present, if data is not present on a particular node, no processing will be done for this particular job. So across the nodes also there is a parallelism. That is why we call this as parallelism inside. This is what we call it to be massive parallelism. Where we have parallelism inside parallelism, at the cluster level there is a parallelism. Within the node also there is a parallelism. That is what we call this as parallelism inside parallelism, which we technically call it as massive parallelism. This is a backbone for your MapReduce architecture. Now tell me, I ask you one classical question here, friends. If I want to process 20 TB of data, roughly tell me how much time it takes. Roughly. I'm saying here roughly, friends, not exactly. If I want to process 10 TB of data, how much time it takes on a Hadoop cluster? Friends, please. If I want to process 10 TB of data, how much time it takes? After listening to all these things, I'm asking you, how much time it takes? How much time it takes, friends?
Will it take like 1 day?
No, the reason why I asked this one is, I want to understand to what extent you followed the concept what I have mentioned just before. Massive parallelism. I said, your job execution is happening at a massive scale across the cluster and within the node, both. So that is where I asked roughly how much time it takes to process your 10 TB of data. Let it be 10 TB of data or 20 TB of data, I can say how much time it takes, to process a 128 MB block, because the block size is 128 MB on the cluster. How much time it takes to process a 128 MB block plus some aggregation time is the time which the MapReduce job takes to process 10 TB or 20 TB or 30 TB or any amount of data, provided the resources at data node level are adequate. Imagine if I take 128 MB block processing 20 minutes, assume. In 20 minutes of time, I can process, not exactly 20 minutes, because now in order to process one block of 128 MB, I take 20 minutes. There are 100 blocks that have been processed parallelly. From all these 100 blocks, I get only partial outputs. All such partial outputs need to be put together to finally give you the output. For that sake, I take some more time. That is the reason why I give you the answer. How much time it takes to process a 128 MB block plus some aggregation time that is needed to aggregate all the data that is output of your mapper phase to finally get the output. That is why this programming model is a two-phased programming model. You don't see this kind of programming model in your traditional regular aspects, friends. You won't see that in your regular implementations. You see only here because of the reason you are not processing the data sequentially. If you're processing the data sequentially, that is one after the other, you don't need two phases. You don't need two phases. One phase is sufficient for you to execute everything. But here, by processing one block of data from one node using one JVM, you only get the partial output. By processing one block, we get partial output. Second block, we get one more partial output. All such partial outputs need to be put together to finally give you the output of your job. Because the output from 128 MB block is not the final output. The output from one 128 MB block is not the final output. That is output of that particular block only. But we have such a, if you take 128 MB, 12,896, 8 blocks per GB, and 1024 GB is, you can understand here, 8 blocks per GB into 1024. 1024 GB is 1 TB into 10. This is the 10 TB data processing. So how many we get? 10240 into 8. That is round about 8 2 9 800 8432 8216 19 1 8. So if you look closely here, it is 81920, 81,920 blocks we get for about 10 TB data if the block size is 128 MB. Are you getting my point, friends, here? Hello?
Not clear, Srinivas. Can you repeat that?
If I have 10 TB data, my 10 TB data is going to be chopped into 128 MB blocks across the cluster. So how many blocks I get? For 1 GB, I have 8 blocks. Such 1024 GBs put together 1 TB. That is why 8 into 1024 into 10, that is 10 240 into 8 is equivalent to, that is 10,240 into 8, that is equivalent to 81,920 blocks I get for 10 TB data at 128 MB block size on the cluster. Hope you are getting the point, friends. So how many blocks need to be processed? 81,920 blocks needs to be processed. And you think these blocks are going to be processed one after the other? No. These blocks are going to be processed. These blocks are going to be processed parallelly. How? Within the data node. Now tell me, this 81,920 blocks will be stored on the cluster uniformly again. What do you mean by uniformly? Few blocks on each data node. If I have my cluster size 30, if I have my cluster size 30, this 81920 blocks will be uniformly divided into 30 nodes. Then only there will be balance across the cluster. All these blocks, I put it in 2 nodes as there is a space available, and that is not the correct approach. Who takes care of this one? Your name node takes care of this one. Though you need not worry for that. Name node is going to decide which block should go and sit where, and whose replicas need to sit on which node. All been decided by your name node only. So we need not worry for that. We only need to worry how we can process the data using the code written by us. That's the only worrying factor. Now I think you understand what I mean by massive parallelism, friends. And you understand the statement what I've given here. How much time it takes to process 10 TB of data? When I ask that question, I have given you the answer. How much time it takes to process a 128 MB block? That much plus the time to aggregate your data, provide there adequate resources available on your data nodes. Because when I'm planning data nodes, I will not be more specific in terms of the resources there. I will not go for very high-end, enterprise class servers when I go with the data nodes. I regularly go with the traditional normal hardware. With normal hardware, don't think that, friends, 2 GB RAM and 1 core processor like that. No. Even you take your data nodes, there will be multiple CPUs and multiple cores per each CPU, at least 128 to 256 GB RAM. That is what I mean by commodity hardware. Commodity hardware doesn't mean your 512 MB RAM. That comes under commodity. Of course, you want to form a cluster with those minimum configured machine. Then also it is possible. But at the production level, you take that word commodity hardware should not mislead you. Commodity hardware, I mean the local hardware which you assemble it and all. There are also the servers from Cisco or Dell or HP, but not the enterprise class or your database class servers. They are not that expensive of that level. So on each node the data is getting processed. So each block will produce some output. If I directly transfer this output from each block to the reducer, there will be heavy network traffic. In order to keep that in the control only, I take the intermediate phase called combiner phase. What combiner will do? Combiner will perform local aggregation on the same node before the output of all the blocks of that node are sent to the reducer. So that what happens, friends, here? What happens? I will be avoiding sending the outputs directly from the mapper phase to the reducer phase, so that the network traffic, what we are avoiding here, is going to improve the efficiency of your job execution. That's what the beauty part here. Combiner is technically called as local aggregate. Not aggregate the data is coming out of that particular node. Make sense, friends? And you may ask me one thing, what is the role of the partitioner here? The role of the partitioner is to decide which key value pair should go to which reducer is actually been decided by the partitioner. Don't worry, I am going to show you that practically, because as I told you, every phase is not going to be developed by you as a developer for every MapReduce job. For most MapReduce jobs, we only develop mapper and reducer, and we use reducer itself as a combiner. So we will not be developing every phase of the MapReduce job on our own in every case. Mapper, combiner, partitioner, shuffle, sort, then reducer. Shuffle sort is provided by the framework itself. In the absence of your shuffle and sort, the framework provided shuffle and sort will work and give you and produce the output. Partitioner also provided by the framework. Which key value pair should go to which reducer is decided by the partitioner. That is also provided in the absence of your own partitioner. Combiner, we need to decide whether the same reducer can be used as a combiner or not. If can be reduced or if it can be applied, then the same is being set at your driver code level. This job.set whatever, the combiner class. We use the reducer class itself as a combiner class so that it can perform the local aggregation. Now it is a time, friends, to look into. It is a time to look into the code of the MapReduce job to understand by going through the API. What do you mean by going through the API? So for each class, whatever I'm showing you here, friends, we have the API available. MapReduce API, I'm going to show you that one. So the immediate phase to us is MapReduce, understanding the MapReduce word count example and going through the MapReduce API. When you start going through the MapReduce API, you will be seeing, this is a MapReduce API. You will be seeing two versions here, friends. We will be working with the latest one. If you go through this, you have r.apache.hadoop.mapred. This is old MapReduce API. You need not touch that one. There is one more thing that is called r.apache.hadoop.MapReduce, which you are seeing here, MapRed and MapReduce. This is called the new MapReduce API. We will be going through this one only. Here they have provided what is a mapper class, what is a reducer class, what is a partitioner, all we are going to see here. But interesting, you don't see anything called combiner here, because in order to develop a combiner, we are going to extend our class from reducer only. That is where I am saying a reducer is going to work as a combiner also. So combiner is called the local aggregator and reducer is called the global aggregator. That is the reason we say. So every line of code that you see here, say for example, when you are going through this code, you come across extends mapper. So where this class is available in your API, that is where we have the class called mapper. When you go here, you understand what is the mapper class, what methods this mapper class has got, and what each method represents, and why that method is required as part of the mapper class. You come to know only from the API. So I want you to go through the API, MapReduce API. When you are going through this word count example, then only it makes sense, friends. Then only it makes sense. Otherwise, by hearting every example and trying to reproduce the same example may be okay, but at times when you need to write your own MapReduce job for a given context and the data set that you are using, then you fail to do that. So you must get the hold on the MapReduce API. And for that sake, you need not break your head to go through the entire stuff what I am showing you here. But at least the few classes. You must go through r.apache.hub.mapreduce. In that, you must go through mapper class, reducer class, partitioner class. You also need to go through the job class, input format, output format. At least these things are essential to start working with your MapReduce API. You must go through this code and what code we are writing inside the map function and what code we are writing inside the reduce function. If you carefully go through this one, then you understand, oh, this is what the logic we have implemented inside the map and the reduce phases of your job, and that is how I'm getting the final output. I've already shown you how we get the output, friends, in the last session itself. You might have gone there and you might have seen what output you are getting as part of that. All the words and their occurrences you are seeing very clearly as part of your part R file. That is the output of a reducer, part R. That is the output of the reducer, part R file. Please go through this code and go through the API, friends. Then only it will be more effective to start working with your MapReduce part. Make sense, friends?
Srinivas, Prasad here. So if you want to create any customized MapReduce job,
Yeah.
so we need to follow the standards using this API only.
Absolutely.
So this mapper class, reduce class is like by default. Okay.
Absolutely. If you want to develop, in fact, this word count itself is developed following this API only. You might have noticed here there is a setup method available, there is a cleanup method available, map method available, and run method available, which are not needed in every MapReduce implementation, but are needed sometimes. When they are needed, you will come to know only when you go through this setup method and understand this setup method is going to be called exactly once. Called once at the beginning of the task. You should not job, task. Called once at the beginning of the task. Called once for each key value pair in the input split. Called once at the end of the task. Expert users can override this method for more complete control over the execution of the mapper, because this run method, what we are writing here, is actually going to take care of your parallelism. Is almost similar to that of your run method inside the thread class. So we should not touch this one until and unless you are going to control, you are interested to control the execution of your MapReduce job. You are not going to touch this. So you come to know the life cycle of these methods and when these are being useful only when you go to the API. You come back here and see you have a setup method here and you have a map method here. Of course, this parse skip file is not the method from mapper class. It is a private method which we developed to be used as part of your processing activity. That is not a part of your mapper class. How you come to know that this is a custom method and these are the methods from your existing API is only by going through your MapReduce API. You want to develop any custom MapReduce job, you must hold or you must get the hold on your MapReduce API. At least mapper class, your reducer class, your partitioner class, your input format, output format, and the job. At least these classes we need to be pretty good. Then only we will get the skill to develop our own MapReduce job in the given context. Otherwise, not.
So what is the maximum limit of the blocks in the data node?
Sorry, please come out again.
What is the maximum limit of the blocks in the data node?
Not maximum number of blocks. That all depends upon the availability of the storage there. There is no maximum limit on the number of blocks. Depends on the storage available. If it is a 10 TB storage, obviously some part is left for your operating system. Hardly that is 10 GB or 12 GB. Rest of all is for your storage only. And I cannot treat the remaining storage to be the complete storage. In that only 1/3. If my replication factor is 3, then 1/3. If my replication factor is 4, then 1/4.
So all this configuration will be taken care of a name node only. So we don't do any coding parts, any logic written in this.
Absolutely zero. Absolutely zero.
Okay.
So that is all been taken. That is what the beauty part of your Hadoop. All the complex logics that are required to store your data, balance your data, manage your replicas, all been taken care implicitly by the name node, without having much pain to the developer. That's the reason why we say it is easy for the developer to focus on what needs to be achieved rather than how data is being stored and where I need to go. Nothing. We only understand, it's all been taken care by the masters. My responsibility is only to develop a job and push it to the cluster. It takes care of executing it. Even we need not worry. But only thing is we need to understand how data is organized and all. Accordingly, we will be able to write the logic more precisely to work in the context that is provided to you. So the immediate goal to us is, friends, understand. Now we have understood how to work with HDFS, navigate the file system, start running the commands to perform your operations, file system operations, and then we move to the concept of running our own MapReduce job packed in the form of a ZAR file. Let it be provided by Apache or Cloudera or your own ZAR file, it is the same story. Once we got the understanding how to run a MapReduce job, now we are going into the details how to develop a MapReduce job. Once we see the output, then only we will be able to understand, this is what the input, this is what the output we got. And we are not trying to understand the code of what is been written inside the map function or the reduce function and all that stuff. Then it makes more sense, friends. Right? So I don't want to overload you much showing many things on you. Please go through this MapReduce job, that is a word count job, by closely working with your MapReduce API. And this will not be a one-day job. This should be a consistent job for the next 1 or 2 weeks. Whenever you find time, go through the API and try to understand, because this will not come just with one session discussion. And you must practice that one consistently. Then only you get the hold on how to work with the API. You want to develop any MapReduce job, it is the same API. And believe me, friends, immediately after finishing MapReduce, we move to Pig. In Pig, what we learn is a layer on the top of MapReduce. You write a script and run it. It works as a MapReduce job only in the background. After finishing that, we go to Hive. You run a Hive query, it looks like an SQL query, but it runs as a MapReduce job in the background. So wherever you go across the entire Hadoop ecosystem, without having the control on MapReduce, it is going to be Greek and Latin for you forever. So the more you focus on MapReduce, you need not develop hundreds of jobs, friends. Even if you develop one job, you understand thoroughly the life cycle of a MapReduce job, why key value pair concept is being used as part of the MapReduce. All these things you understand precisely. You need not write 100 examples, but you can gain the knowledge to write any example in the future. We need that skill set. We don't need the skill to write 20, 30, 50 MapReduce jobs. We need the skill set to write any kind of MapReduce job, understanding one example. Because writing examples is limitless. So depending on the context, we write. So that is why I advise you to go through this code. Wherever you are seeing a new entity which is not covered as part of your Java basics, immediately you should search for that in your MapReduce API. Then only it will be easy. I think you noticed, friends, I don't know whether you gone through that or not. The output key class type is text, which is like your string only. But there is a separate class equal to string in the MapReduce called text. The output value class is int writable. We have an integer object in Java, but we have int writable here. So what are Hadoop data types? We see in the tomorrow's class. Don't worry. Don't break your head. Hadoop data types we see in the next session. But before that, you need to understand, oh, text is a class. Where you find this text class? One more package where we need to be very strong. r.apache.hadoop.io. That is one very interesting package and very useful package across. r.apache.hadoop.io. We have an interface by name writable and writable comparable. Whatever I'm saying here, your int writable, long writable, text writable, byte writable and all. Along with that, we have something called text, which is nothing but string equivalent. You can see that here text is implementation of your writable comparable interface. And this is to store only your text data. Don't worry, friends, we talk about that one. But if you find time, I advise you to go through r.apache.hadoop.io package also, which is very important for writing your MapReduce jobs. These two, if you are able to go through thoroughly, at least for this initial stage, we will be fair enough to start working with your MapReduce job implementations. Make sense, friends?
Srinivas, have a question.
Yeah, please.
Yeah. Actually, I was trying to understand the Hadoop cluster concept. As I understand, I might be wrong. I understand like a cluster consists of multiple name nodes. And my question is like, do we have such multiple clusters in the Hadoop ecosystem?
No.
Or the Hadoop environment?
No, every Hadoop cluster will have exactly one name node, one secondary name node, and n number of data nodes. That is, we call it as one Hadoop cluster. Like how?
Right.
Like how a family, father, name node, mother, the secondary name node, children, the data node, something like that. I mean, don't compare the roles and responsibilities and understand this example. Something like, in the absence of the father, the mother, but not directly, it all happens to the father only, but it works as a backup to the name node, the secondary name node. So name node, secondary name node, and data nodes put together a cluster. Like how we call it as a family, father, mother, and children. We call it as a family. So name node, secondary name node, and data nodes put together a cluster. On this cluster, we also has got the processing power that is in the form of job tracker and task tracker. These are all the daemons that are going to run on the respective physical machines. All put together, we call it as a Hadoop cluster. Yeah.
Srinivas, so in the MapReduce job, this mapper reducer class like a little confusing. Like what exactly the logic we are going to write in the mapper and reducer, how this combiner is going to work. This is a
Now
little confusing actually.
you should stop thinking it as a traditional. That is why I mentioned it very clearly. You should stop thinking this as your traditional programming model. In the traditional programming model, you are going to write the code keeping your data to get processed sequentially. But here the data get processed parallelly. Okay. So all your mapper phases, I mean, when I'm processing my first block, only the mapper phase will function. Second block, mapper. Third block, mapper. All mappers only will function. When all the mappers finish their execution, then the reducers will come into picture. It is not that mapper and reducer work hand in hand. When all the map phase is done, then only the reduce activity will get initiated. So inside the mapper, and again there is no thumb rule that we need to write this code. That all depends upon the context. If you see closely here, in the word count program, in the map function, we are just converting each line into tokens. For every token, we are fixing a standard value called 1. I mean, if I am going to process, that is the reason why I am asking you to go through this code and apply to the word count what we have achieved. Say, Mary had a little lamb is the first line that comes to your mapper. Okay, then what the map function will do is, map function will make this as Mary 1, had 1, A1, little 1, lamb 1. Like that it will convert. What the combiner will do, all mappers output from the same node will be summarized. What summarized? If Mary occurs 4 times from different blocks on the same node, then Mary 4, had 2, little 2, lamb 3. This is from one node. This is from one iteration of map function. Mary 56 had 121, little 89, lamb 250 or 245. This is output from reducer. Now I think you understand the point, friends. From each iteration of the map function, we get the output like this. There could be number of iterations to process one block. From one block, we get the output. All such blocks from the same node will be combined using the combiner, so that from that node we get this one. So instead of me transporting Mary 1, Mary 1, Mary 1 number of times, that is 4 times from one node to the reducer, because reducer runs on a different node. Instead of me transporting Mary 1, Mary 1, Mary 1, Mary 1 4 times, it is good if I can process it as Mary 4 and pass it as one key value pair to my next level. It becomes easy. That is the reason why we are taking the support of your multi-phased activity when it comes to your MapReduce job than your traditional programming where you process data sequentially. That is the reason why I'm asking you to go through this code precisely to understand. Oh, that is why we should keep your input. That is, Mary had a little lamb one side. Go to the map function. What might be happening here? Oh, this is this thing happening. Fine. So when it goes to the reducer, what is happening? Oh, this is the thing happening. The final output is this. Wherever we are going through this new class or new entity, refer the API to understand better. May not be completely in one single shot. At least till you understand your MapReduce, work on MapReduce job thoroughly, you do that. And the rest of the things we do, over a period of time. Your text class, your int writable, long writable, float writable, all these things we see in the due course. May not be in one single shot. Definite, after going through all these things also, you'll be having number of queries. Don't worry and don't hesitate, friends. You always has got that freedom to ask me any question in the next session, but make sure that all related to MapReduce we cover and we clear when we are about to finish MapReduce. Not like you ask the question on MapReduce when we are about to finish the course. You are the loser. I don't have any pain in answering the question on MapReduce. But you will be, if the same query is continued till the end of the course, your all learning process is being impacted very badly. So to make it more fruitful, work hard parallelly with me. 1.5 hour you are taking session. At least 3 to 4 hours you need to keep from your end, an average. May not be every day, at least weekend you sit for 8-10 hours, something like that. Then only you will be productive. You just go through the recording once again will not get you anything until and unless we start practicing it on our own. So I'm sure you'll have more queries even after going through the code. Don't worry. I'm there to help you out to understand better and visualize how your MapReduce job is getting executed.
Yeah, okay, sure.